Hello students, today we are going to start with the new chapter, electricity. Now electricity is a term which is controlling almost all aspects of our life, and it is also facilitating all our needs. For example, right from your watches to your mobile phones, from your PC laptops to your electric doorbell, from your water heater geysers to electrical cushions, everything is dependent on electricity, right? So it is actually a comfortable, convenient and controllable type of energy which can be used in almost all sectors of life. So let's start studying about electricity. What is electricity? And first of all, we are going to study about electric current. Now when we say what is current or current is flowing, or when we say the current is not proper, what do we mean by current? What exactly is happening in the wires when we switch on a light? For example, you switch on the light of your room right now and you will see the bulb start shining. Now what exactly happened between the wires and the bulb so that the bulb started shining? When you switch on the fan switch, what will happen? Your fan will start spinning. So again, what exactly is happening? We all know that current is flowing through the fan, current is flowing through the bulb. That is why bulb is glowing, that is why fan is rotating. But what exactly is current? Where does it comes from? Where does it go? So that is all we are going to study right now. Okay. First of all, to understand the gravity of this concept, I will walk you through, I'll explain you some concept which is not in your syllabus, not in your book, but you should know because you'll be studying the same thing when you'll be going to higher classes. Okay, I'll be telling you about how current flows and what exactly is current. The basic definition of current is rate of flow of charge. This is your textual definition, the definition which is written in your books. Rate of flow of charge. This is what current means. Current is denoted by term I, which is charge. Rate means the rate. Whenever this word will come in your physics, even in your higher classes, that means the physical quantity is getting divided by time. So charge upon time. Alright. So charge is represented by Q, time is T. So this is the basic definition of current, rate of flow of charge or charge upon time. Now, to understand what charge is flowing in what time, you'll have to actually examine a proper wire. Suppose this is a wire. I've connected a cell, a switch, and I've also connected a bulb. These are few symbols which we are going to study in our next topic. So what I have connected? I've connected a cell, I've connected a switch, and I have connected a bulb. Now, all of us know when we'll switch on this thing, when I'll make this right now, it is an open circuit. Open circuit means the circuit is not complete, it's a broken or open in a part. But if I close the circuit, closing circuit means I'm switching it on. Okay, so when I'll switch on this device or when I'll close the circuit, what will happen? Current will flow in the circuit and bulb will glow, right? If the circuit is switched on. That is what I want you to know, what exactly has happened. What is charge and which charge has flown. To understand this whole concept, I'll enlarge this wire. Suppose this much part, I'm taking this wire and I'm showing it to you, the enlarged version. Suppose we are viewing this wire from a microscope or we have enlarged this image 100 times. So it's something like this. You will see a cylindrical shaped wire. Okay. Let's say this wire is made up of either aluminium or iron or copper, whatever. So any metal. So the wire will consist all the atoms or molecules of the constituting material. Suppose it's an iron wire or copper wire, so you will see copper atoms, right? Or iron atoms or aluminium atoms, something like that. What is charge now? In your chemistry classes, you have learned about basic atomic structure, which is like this. If this is an atom, at the center there will be nucleus. Inside nucleus you have positive and neutral atoms. What are positive atoms? Positive atoms are protons and neutral atoms are neutrons, right? This we know. We also know that there are electrons which are revolving about the nucleus in circular orbits, right? So outside we have negative charge particles which are called electrons. Now, point is, what do we call those electrons which are in the outermost orbit? We gave them a name of valence electrons, right? These are valence electrons. So, how do valence electrons take their place? Suppose there is an electron in lower orbit, it will gain some energy. The energy can be supplied to that electron in any format. Let it be heat, let it be room temperature, anywhere. So that energy will be acquired by the electron which is revolving in lower orbit or inner orbit, and it will keep jumping up to higher orbits, right? So the electrons which are rotating or revolving in the last orbit, they are called valence electrons. This is a term which we are now familiar with. Now what will happen if I supply some more energy to those electrons which are already in the outermost orbit or valence shell? The thing which is going to happen is that this electron will come out of the atom and it will be free. It will be free to move anywhere in the void. Void means empty space. So these conduction electrons are, this is called conduction electron. Conduction electrons are the electrons which actually leave the outermost orbit or valence shell. They jump out of the atom. Now they are free to move anywhere throughout the structure. So this is a charge which can move freely, and this is how this wire portion would look like. It will consist of all these atoms or molecules of the wire which it is made up of, plus it will also have those free conduction electrons which are free to move in any direction. So these are actually free charge, though they are negative charge, but these are the free charges which are already eager to move, which are already free to move anywhere. The moment this switch is closed on, the moment the circuit is closed, this cell, it provides them a push in a direction given by this cell, which we are going to study in next topic. So this cell provides them with some push or some field due to which they all start moving. And when the charge, all this charge, this is what? The free charge, free electron, this accumulatively, the complete charge is the total charge which is moving and the time in which they are moving. So this is the charge which actually moves and they constitute current. So now you have the slightest idea what charge moves and what exactly is current. Current is rate of flow of charge. Which charge? The free charge which is already present in a conductor. It is in the form of free electrons which are freely moving anywhere or in random directions inside the conductor. But when some external source provides them a definite path, they all start moving in a single direction and they completely form the current. So this is current, this is charge and time.